Okay, so welcome everyone to the Python Workshop 3. This time we have partnered with both IEEE and Robotics to bring you some nice little learning material to get you started on your journey as a Cal Poly Pomona engineer or student if you are not an engineer. These skills will help you along the way either way, so that's our hope. So today, we're going to go over a few things. So from the last workshop, we had our problem statement that I introduced at the end. We'll go over some solutions to that. And then we'll go over a few things, important things like functions, and how we can use functions as applications into our systems. So when we're designing code, how do we use functions in order for us to repeat different lines of codes, but keep our code base intact and very simple to understand. So, and then after that, we're going to go into socket programming, which is kind of like a really big thing, because when you're doing when you're taking a coding class here at Cal Poly, the next thing after functions would be classes. But in Hyperloop, we're taking a sharp left turn into sockets and servers, because when you're coding in Python, for robotics, most of the time you're going to be trapped in a place where you're going to start using dependencies and other files to manage your code. And in functions, we'll talk about how we can use different dependencies to shorten our code and some examples of how to do that. But as of right now, socket programming is going to be our end goal for today. We're going to learn how to set up a server and a client. And we're going to establish a connection on our local host, which is our local computer. We are also going to be going over the process on how socket works, how we can set up a echo protocol, and then maybe even make a chatbot if we have time. We have time for questions and answers. All right. So in the previous workshop, I don't know if anyone here has gotten the memo or has gotten up a solution to this, but we have this problem statement. So we need to write a Python script to follow the description of a realistic control system. And the control system says the following. The CPP Hyperloop pod is accelerating to a speed of 200 miles per hour from an initial velocity of 0 miles per hour, which takes about 7,200 milliseconds of time. If the time is at a multiple of 100 milliseconds, we will retrieve a data point from the IMU. If the time is at a multiple of 750 milliseconds, we will retrieve a data point from the DS18B20 temperature sensor. If the time is exactly at 5,000 milliseconds, the pod will autonomously retract its brakes and prepare for travel at full speed. When the pod reaches maximum speed, it will print out the number of data points from the IMU and the number of data points from the temperature sensor that the pod system took over the course of the startup sequence. And so I did receive a few code submissions over my private Discord, which was really nice because I got to see what your interpretation of the problem statement is and what your solution was. And so there are multiple ways to solve this problem statement. It's specifically made to be this general for a reason. And I'm going to go ahead and share the PowerPoint so you can see the prompt. It's very short this week. I was actually restricted. I'm showing the link. And I'll put it in the chat so you guys can go ahead and view it. But as of right now, I'm going to switch to my other screen so that we can go ahead and begin coding a solution to this problem statement here. All right. Okay, so we're going to open up our GitHub desktop. Remember, we go to repository, open in Visual Studio Code to go ahead and open up our code base here. So last time, we went ahead and went over loops a little bit. We went over while loops. We went over for loops, and we specified why each loop is important for what case. Now I'm going to go ahead and just make a new file. I'm going to name it Hyperloop prompt.py. And I'm going to go ahead and copy paste our problem statement from here into a comments. Okay, so, oh boy, just split this up into a few lines here, so it's readable. Breaks, statements. Okay, it's very wordy, but let's start coming up with a solution to this. So if the pod is accelerating over 7,200 milliseconds at a time, and in that time base, we need to do a couple of things. Does anyone have an idea of where to start? What is the first thing I should think of based on the stuff we covered last week?
I would start with a while loop. So while time is less than, what was it, 7,200 milliseconds?
Okay, so let's go with that. So while the time is less than 720 milliseconds, let me just make sure time is a variable. All right, and let's get some chat input because I want to see how you guys think of these problems, because your solution may be different from mine. So at this point, what's my next step? Import Numpy. Numpy is usually used as a number formatting dependency. We're not doing any complex math here. We don't need to like include any arrays. So I do not think we need to import Numpy because Numpy is just like something extra we put into the code to get more mathematical functions involved in Python. So I see here that Addy suggested a while loop, which is correct. If time mod 100 equals 0, good. So let's say if time mod 100 equals to 0. So she's looking at if the time is at a multiple of 100 milliseconds, and then we will retrieve a data point from the IMU. So I'm going to do print IMU data. All right. So that's our first statement, right? If time mod 100 equals 0. Now we have a next statement here where if the time is at a multiple of 750 milliseconds, we will retrieve a data point from the breaks and prepare for travel with full speed. Now, does the change in the amount of time affect our results or affect our code base? Can we just copy and paste this again? So we can definitely copy paste this again. I see Andres in the chat says if time equals 5,000, and I'm assuming that you say if the time is exactly 5,000, it will retract its breaks, right? So I'm going to go ahead and do 750 here. So if the time is at a multiple of 750, now I practically give you the answer in the wording there, but you are correct. If mod 750 equals 0, we're going to do temp data received. Okay. And then if the time is equal to 5,000, I'm going to print breaks retracted. All right. Okay. So now how do we solve for the last statement? If I run this code, what do you think will happen? If I just press play right now, what will happen to the code?
Nothing, because
won't be able to break out.
I heard nothing, and I heard it would break out.
Oh, it wouldn't be able to.
Let's try it. All right, let's press play. So on the bottom terminal window, you can see the output of the code. Now press play. It's interesting because it does output something, but it never stops. And can anyone tell me why that is?
Because it's always equal in 0?
Yeah, because we never change the value of time. Turing machine will never hot import time. Now here's the tricky thing, right? We can import all the stuff we want, but are we really going to use it for anything practical? Because right now, what the problem statement just says, it's we can just have the time like that, except for the fact that let me just Control C. So whenever you want to just like destroy a script, you just press Control C. It's a keyboard interrupt, and it gets you out of there. So we didn't change the value of time. So I have to do time plus plus. Not plus plus, that's C++. In Python, plus plus actually doesn't exist. So if you're used to that, just use plus equals. Time plus equals 1. And that in here, I'm going to use an F string to actually just tell me the time. So I'm going to do IMU data retrieved at time, which will tell me when it got retrieved. So temp data retrieved at time and then breaks retracted at time. And this will tell me if my statement was correct or not. So I'm going to go ahead and run this. You can see that there's a lot of IMU data. Oh, I didn't put an F string here, so I just thought I said time. But you can see that at a multiple of 100, the IMU data gets received, and then every 750, it retrieves temp data. So that's how we can use F strings to tell us when the time is. And then it'll end when it hits 720, 7,200, all right? There's a way to optimize this code even further. Remember during the last workshop when I said, or when I explained the difference between using a for loop and using a while loop? Does anyone remember why we use a while loop or why we use a for loop rather than a while loop?
Because we know when it ends.
Right. We use a time plus equals 1 will not be a representative of when a millisecond has elapsed, I think. That is good. That is good. That is a good observation there. And you are correct. So to account for that, we can import time. But at the same time, we are technically not getting our data in. So I'll go over import time right now. So when we're importing dependencies like time, we do import time here. We can use specific functions. However, this will destroy all our variable names because time is now a keyword in which I didn't want to have. So now we're going to have to use like a time D or something like that, just to make sure that we can use the variable and not have it be a keyword all over the place. So you're right. If we want this to be very accurate, we'll go ahead and do time.sleep. And then 1 millisecond would be like this, 0.001. Because if you look on the description here, time.sleep in seconds will delay the execution of the code for a given number of seconds. So it may be a floating point number for precision. So this would be 1 millisecond. So if you want to be very precise, this is how you do it. But if you want to be really, really precise, let's say in the Hyperloop situation, it's not going to just take 1 millisecond to loop. Taking this data, if you're grabbing data from a sensor, that takes time. And if you're printing it, this actually takes like 4 microseconds. And so if you're saying that exactly 1 milliseconds, that wouldn't be true because you also have all these other contributions to your time that you're not actually taking into account of. So just keep in mind when you're working with this, it's very, very tricky. So import as time equals start. Or time.start. I think that will work too, but I just like using time.sleep because that's just the general delay. If you use async time.sleep, then that's an asynchronous sleep schedule up there. But I'm going to go ahead and vary that using a for loop is better because, as Addie said, we know when this ends, right? We know when this ends, which is at 7,020. I'm going to keep butchering that throughout the entire lesson, but we know that the code ends at around 7,200 milliseconds. Therefore, we can just replace it with a for loop. Now, a for loop is like at the syntax. So I'm going to use x as a variable. So for x in range, and then 0 to 7,200. Now it's going to yell at me. It's going to yell at me because 90. Okay, never mind. It's not going to yell at me. I thought so x is going to represent our time variable here. You don't need timed anymore. And then this is how we use dependencies inside our actual script. So if you are in Hyperloop and you look at the code, I actually do have time.sleep placed in various places throughout the code. Because if you have an infinite while loop and it loops too fast, it'll actually break the code. If you have some other dependency being dependent on your script here, like say you have, let's say you have a IMU or you have a temperature sensor that's trying to get data inside, but you're looping way too fast. The code can't keep up. The whole thing's just going to break down. So you want to try to avoid forever loops. And if you do forever loops, just use time.sleep. So that just like makes things a lot easier when you're dealing with real life applications of this. So I'm going to go ahead and run this. Okay, why is it going so slowly? Yeah, it's going really slowly now, which is interesting. I don't think it can handle that much precision. I'm not sure why it's happening so slowly. It's not supposed to happen like this. But that's interesting. Could you take 7.2 seconds? Yeah, it should take 7.2 seconds. But if I do time.sleep, I think it slows down a bit. Let's see here. For milli in range, 1700. Yes, that is correct. I'm just looking at the chat here. Seems to be a delay. This seems like it's at 1 second intervals, which means it's reading the code every 1 second in this for loop. Seconds. Yeah, it seems to be happening for way longer than anticipated. But that's just a general usage of time.sleep. There's probably something in here that's causing this to lag. Yeah, I did try that. I'm not sure. If you're looking at this later on through a YouTube video, feel free to try this code out and tell me if it works or not, because right now it seems to be going through it very, very slowly. I'm going to move on, though. We're going to move on to functions. So function calls. I'm going to just piggyback off this code here. Not sure why for loops are slower than the main function. Let me see if I can comment this out and see if it still works. Okay, it does work. I just don't know why sleep isn't activating right now. But if anyone has any ideas, I'm all ears. Okay. So function calls happen when we need to repeat the script multiple times. It's usually the reason we use functions for. I'm going to create a new script called functions.py. Yeah, I don't want to delay this too much. And we're going to go ahead and create this prompt here. So I'm going to say reoccurring Amazon order. That function pass, that's correct. So I want to buy, I'll say 3 Arduino Nanos. Arduino Nanos every 4 months. Nanos every 4 months. Something like that. And we're going to create our function using the def keyword. So def stands for define. And then we're going to put in our function name. So I'm going to put in my function name's order. And then we're going to do pass just so it doesn't yell at me. So our Andres here seems to be the expert on this. But in C++ and C#, you would usually call this function multiple times, or you would define what it returns. And the difference in Python is that you don't define what it returns. It's like a variable. Because in C++ and C#, which is memory dependent, you would go ahead and you want to make sure that you're very specific as to what the function does, which is why you would usually do like int order or string order as to what it returns. And you can do that, what Andres said in the chat. It goes to none and pass, which is a void statement. But as of right now, I'm just not going to define it. It's easier to understand for beginners when you're just starting off simple like this. But I'm going to have a main function, in which main usually is the script in which you run things from. So let me just print hello world. Optional only needed for Numpy. Yeah, that's good. But I'm going to go ahead and do a if. So if, let me see what this is. If the name of the script is equal to main, then we're going to run the main function. All right, so usually when I write these scripts for my projects, I like to include this just as a failsafe. So what this does is it basically means that when you run the code, it will, well, this is always going to be true unless you're doing something weird. So it's always going to run main. So this is how we control what's being run at the start of the script. So let's say you have multiple different functions and you want to test them out individually, and you don't want And you don't want, yeah, you can watch that later. Excellent video on if name equals main. This chat's not going to be on the chat's not going to be on the YouTube video though, but if I remember, I'm going to link that video into the recording. So we're going to call the main function based on when the code runs. And if I want to test the order function only, I'm just going to change this to order. Like so. And if I do order like this, I'm going to say something like by Arduino nanos, something like this, and I run the script. Scroll down here. It'll call the order function instead of the main function inside line 9 and 10. However, if I switch this back up to main, main without that, then I'll just call hello world. And so this is pretty much going to run at the start of the script. In C++ and C#, you may have int main, which is the default function. And then in Python, you just have this, and then usually we just link it to main. You can call functions inside other functions, functionception, kind of. So if I want to call the order function from the main function, all I do is just do order. This. So what this does is the code will run through the functions. It'll define order, it'll define main, and it'll go to line 10. It'll actually run the code now, and then it'll go to line 11 and then run the main function. The code will then loop back to line 6 and start running through this function, which it prints hello world, and then calls the function order. Now, when it calls the function order, the code jumps back to line 3. And in line 3, it defines it as print by Arduino nanos. And so print is just a command. It prints both hello world and by Arduino nanos off to the terminal window. Okay. And so we're going to go into a secondary topic in functions called passing in arguments. Now, the same thing of same thing as literally everything else in Python. Very simplistic. You don't need to define variables. You don't need to define your return of your functions. You don't need to define what type you're passing it into the function. So, what type your argument is being passed into the function. So let's say we have, number of Arduinos. And the space / extra line is what causes it to exit the function. Yes, so Python is heavily based on indentation. So because there's no semicolons, you can't do the same thing in C# where you can like write all the code in one line. You kind of have to space it out and make sure you put your tabs correctly. So here, my indentation is 4 spaces. You can also have your indentation as 1 tab. You can change it down here in the bottom right corner. If you go ahead and select this or select the spaces equal 4, you can go ahead and do convert indentation to spaces or convert indentation to tabs. And so you can just highlight the entire thing and then convert. It's really useful because some people, I'm going to say this right now, but I do sometimes reference code from popular websites such as Stack Overflow. And when I do that, I have to sometimes copy and paste the code into my compiler to see if it works or not. And sometimes the code I copy will be in the wrong indentation. It'll be in tabs instead of spaces. So here I can just go ahead and highlight the code. I can go to spaces, convert everything to tabs or to spaces or whatever my code base is in, and then it'll work. So it's really a matter of choice. And I see that Andres is saying that IRC, the PEP 8 specifies that you should use spaces and tabs. Yeah, PEP 8 is like the formatting guide for Python. And I think it's the default for Visual Studio Code. Spaces are preferred, that is correct. However, if you try to copy paste code from online, most of it is tabbed instead of spaced. So you can just, that's a way to convert it if you ever like testing and debugging. To pass in, I went on a huge tangent there, but we're going to pass in arguments now. So inside this function of order, I'm going to say num of Arduino equals number. And then I'm going to say inside order, I'm going to pass in a parameter called number. And I'm going to call order using a number, which is an integer. So I'm going to say my number is an integer. Oh, I'm also going to comment this line saying that this will run on startup. And then I'm going to say order function. And then I'm going to pass a number of Arduinos, return, let's say return price. So because Python does not have a defined data type for like return and like outputs, it's really good to leave line comments every so often, just so if you're passing this code off to someone else, they know what the function does. Because sometimes inside C++, it may be easier to not write comments because it's easier to, I guess, see what the function does. You have the information such as the return types and the outputs, but here in Python, you don't have that luxury. So either way, it's a good way to go ahead and make sure that you are very specific in your coding and making sure you have lines, comments, and everything. So this is just the reason for that. We're going to pass in a variable called number, and it's going to print by Arduino Nanos. It's going to set my variable number of Arduino, spelled that wrong, to my number parameter, which is the same thing as up here. So inside my order function on line 10, I'm going to say order 3. So I'm going to order 3 Arduinos. And this number is an integer. So if I'm passing it to number, it's going to set number of Arduino to number. And then I'm going to go ahead and say price of Arduino is equal to $5. And something about naming namespace here. How do you name your variables? There's like a high debate about this. You can use camel case. I think I like using camel case, but sometimes I just put it in like one line like this. Num Arduino, something like this, and then price Arduino. You can also use underscores. Underscores are fine as well. So price Arduino like this. But it's up to, I guess, your preference as to what you like to name your variables, as long as they are very well defined. Just making sure that's the case here. I'm going to print by
just Bob. I
mean, if we named it Bob, then that wouldn't be like too specific, right? You want to at least, yeah, you want to.
Terrible function name. Sorry. Continue.
Oh, sorry about that. You're cutting out there a little bit, but I kind of get it. Just you want to make sure that your variable names are specific and that you can, when you're referencing them, PEP8 specifies underscores if I recall correctly. Maybe I don't memorize PEP8. I probably should, but like I know that PEP8 is kind of strict on these things sometimes. I'm going to go ahead and return my total. I'm going to return my total price. Let's say my price of Arduino is $5.50. You know, inflation happens. I think right now is actually, yeah, it's $5.30 for an Arduino, which we'll have an Arduino lab at a later date, but this is just a theoretical number. So I'm going to return my number of Arduinos multiplied by the num Arduino times price Arduino, like so. And if we want to play the game of spot the redundancy, this is a really redundant line here because we can just reference the number variable down on line 8. We can just say number times price Arduino. We don't really need this variable here. The reason I created it is just so we can see that the variable name specifies what's going on. So the number Arduino times the price Arduino will give us the return of the order. So return, instead of price, I'm going to just return total amounts, total costs as a double or a float. So this will return us as a float, and we'll go ahead and do a print order 3. Because now we know that the order 3 function returns something. So we could go ahead and use an F string and say, your total order cost is, and then we can say order 3. Yeah, inside the F string. And then run this. I'm going to get rid of this. Actually, to keep this interesting, let's ask the user how many Arduinos they want so they can go ahead and call this. So I'm going to go enter the number of Arduinos you would like to purchase. And then we'll use the input function. So I'm going to say number equals input. And then I'm going to put number in here. Okay.
Don't you need to convert that to an int?
That's correct. Thanks, Addie.
Sure.
That's extremely correct. I would have gotten an error then, not a string, but an int, because input returns our values as a string, so we need to convert it to an int before passing into number, because we say passed into the number of Arduinos as an integer, and return the total cost as double. So I'm going to go ahead and run this code. And it says enter the number of Arduinos you'd like to purchase. I'm going to say I want 6 of them. And whoa there, that's a lot of decimal places. It says your total order cost is 30.9 with a bunch of zeros and twos. And so to fix this, I'm just going to have a round function. So the round function just takes your number and it rounds to the correct number of decimal places. So I'm going to say 2 decimal places. So when I run this again and I say I want 6, oops. I'm going to look to buy 6 Arduinos, please. And my total order cost is 30.9, which sounds correct. And I believe that is it. So for a problem statement like this, if you want to make a calculator to see how much, I guess, you have to purchase of Arduinos, I guess this is just a theoretical one. You can also use the decimal module import decimal. Yeah, I try to stay away from imports if I can, because I just don't like using them. Plus, if the less you use, I guess, external dependencies, the better it is for your general audience. Because if you use less, then your general audience everyone starts with a general understanding of Python. So if they understand the Python-based functions like round and order, they don't need the external dependencies. They'll have to go ahead and search up the documentation for it, like I will, because I'm not familiar with import decimal. So if you use that, I will just be like, okay, now I have to go search up the decimal documentation to see what's up with this dependency. All right, the last thing we're going to do before moving on to socket is I'm going to introduce how to import functions from another file. So I'm going to say shop, or I'm going to say shop.py. And inside shop.py, I'm going to copy and paste my order function. I'm going to paste it here. And now this shop.py is in another file, but I want to reference it for my functions.py. So what I need to do is I need to import. This is where the import stuff begins. And I'm going to import shop.py, or not .py, I'm just going to import shop. The caveat with this is that shop.py needs to be in the same or lower root directory as my main functions.py. So since shop.py is in the same folder, I can use it as a dependency. If you've ever worked with MATLAB, this is the same concept if you're using .m files. But as of right now, it says that my order is an unknown function. I don't know, it doesn't know what this is. To make it a known function, all I have to do is I have to put shop.order. And now it'll work the same. And this is good because I know that order comes from the shop dependency, which up here, it's imported. And since it's a local dependency, I can just go to shop.py and see what this order function is. So when you have a lot of dependencies that you don't want to put in one file, you can split the functions up into separate files so that you can check it individually. And this really helps with debugging because, you know, I hate debugging, I hate troubleshooting. The more I can make it easier to see, for me to see where the error is, the better. So if I have a piece of code with like 1,000 lines, like 50 different functions, it's going to take me a long while to scroll through all that. Compared to if I just put it in a separate file and go ahead and reference it later. And that would be much more efficient. Now, I'd like to teach you a shortcut. Let's say you know exactly what shop.py is. You can use the keyword from import, from shop import order, like this. And then you no longer need the shop dot. You can just put order number again. And it works the same thing. So when you say from shop, the code looks through the shop.py, and then you're going to say import order. So it's going to put this order function inside the scope of this script right here. And as you can see, it still works the same. So if I order 100 Arduino Nanos, it's going to be $515. So I think that's all I wanted to cover for functions. We went a little bit over time, but we're going to begin socket real soon. Now I'm going to just briefly pause here to allow you some time to look at both of these. You can actually in Visual Studio Code, if you want to like do a split screen, you can drag it to the side here. I'm just going to allow 2 to 3 minutes while I go take care of something for you guys to copy this down if you would like, and maybe test some stuff too. Maybe when I come back, we can do a little showcase before we move into socket, which is more complicated, I guess. All right, have fun, guys. We'll be right back. Okay, went to take care of the deed and we're back. So does anyone have any questions before we move on? Anything at all? This recording will be posted on our YouTube channel at Cal Poly Pomona Hyperloop. We have all the previous workshops on there as well. You can go ahead and reference it. I'll drop the YouTube link right here if you want to just reference it. These are public videos. We only unlist our general meetings, so you can go ahead and look at them later on. All right, I don't know if I just, okay, I paused the share. I didn't pause the recording, so there's gonna be like a 1-minute gap in the recording, yes. But it's a breather because I like to go fast and I'm not sure if the room can keep up. So just make sure I pause every once in a while to check if you guys have any questions. So you're free to interrupt me at any time. I do read the chat. I feel it's very interesting sometimes. But we're gonna move on to socket now. So this is something unconventional and it's not covered in like regular classes, which is why you guys are here, right? You're here to learn something that's not being taught in like the main classes or something you can't find online, which is experience from Hyperloop members. So what we're going to do next is we're going to go over a quick flow chart of what socket is. And so socket programming is really powerful because it allows us to send data from one place to another. We can send data from my computer over to my Raspberry Pi, which is across the house. I can send data from my Raspberry Pi over to someone's computer like 50 miles away. And we can do this like using a virtual private server. When we transfer data to the virtual private server, we also do this using a socket connection. But there's some issues with like firewalls and security that we'll talk about maybe later that we don't have to worry about yet, because sending data from one place to another requires kind of like a firewall breach. But that's why when I try to set a server up at school, it wouldn't let me because the school's Wi-Fi is a bit questionable at times. But let me go over a quick flow chart to document or to demonstrate how this procedure is done. So I like using this flow chart to describe the relationship between a server and a client. Usually when we're describing these things, we usually have a server and we have a client. And our server, we can only have one server. That's the central point in which all clients are connected to. So we can have one server, but many different clients. It's kind of like going to a hotel, right? If our hotel is the server and we have a bunch of people wanting to get rooms, they are the clients. And the clients will go into the hotel and stay there a little bit and then leave. It's kind of the same thing with what we're doing here, except we're using it to transfer data from one place to another. So we'll have a single Python script, and then we'll have another Python script talking to each other. And in this example I'm going to show in a few minutes, we're going to do this over localhost, which is the address is 127.0.0.1. And it's pretty much just like your local internet and devices around your area can connect. And we're using this as a way to connect your device to your computer in case you don't have another device to test this on. So it's very, simplistic for now. On the server side, there are a few functions we must run to set it up. One is the bind function, one is the listen function, and one is the accept function. These three are like preliminary functions that set up the server. Listen will listen for a specific, however many clients you want. So you can limit the number of clients in this function here. Bind will bind it to the host name. So basically what you say is the server will try to bind itself to whatever internet you're on, but you need the specific IP. So based on the computer's IP, that's what it's going to put out and onto like the interwebs, onto the cloud, and wait for other clients to join using that same address. We're going to go ahead and also go accept the connection, just so we can have the connectivity established. And then it's going to go into this forever loop here, which is the synchronous echo protocol. And on the client side, we have to also create the socket using socket function, and then we're going to connect to the server. It's very simple for the client since the server is already established. And under here, we have two functions which are really important. We have the send function and we have the receive function. And so the server and client communicate each other through TCP UDP protocol. They establish a handshake between the two connections, and then they can pass information to one server to another. This is what we call bicommunication. So in terms of the Hyperloop pod, what we have is our Hyperloop pod sending data to our computer, and our computer sending data back to the Hyperloop pod. And so this two-way communication is what allows us to both control what the pod is doing and both control how we can receive data from the pod, which has to be very efficient in a way. So RECV stands for receive. We're going to receive some data through here, and then we're going to send some data outwards. And echo protocol, what happens is that we have a client that sends a piece of data to the server. And then the server immediately sends the data back to the client, which is an echo kind of. You think of it as a ping pong kind of logic, just to make sure that the server works and that we can send data successfully. When we get the echo protocol working, there's a limitless amount of things you can do with socket connections. I have built a Twitch bot on Twitch, the streaming service, using IRC bot, which is a version of socket connections. So it's a port from my computer to the Twitch website, which controls an account on there. And so that's kind of like one of the applications. The other application, of course, we use on Hyperloop. Maybe if you would like some kind of server connections, maybe if you would like to set up like a mobile webcam to monitor your house for security reasons while you're away on vacation, you can go ahead and set up a socket connection, a manual one to connect your computer. If you already have one of these security systems, by the way, this is pretty much how they connect through the socket. So I've ranted long enough about this diagram here. I'll show you another diagram, which is from one of my projects. If you're from Robotics, I'm sure you've attended Chris Watson's workshops where he pulls from different projects, and this is one of them. So this is a timeline, I guess you could say, from left to right, that documents the relationship between a camera sensor and a robotic arm. So you can see here, when the data goes from the green line to the yellow line, it has to go through a socket connection. It has to go through TCP. And this communication will can send in data packets by the use of JSON.dump. So it sends an entire JSON file over to the other script, in which the other script can use it to analyze different parts of it. So when we're transferring data from one place to another, we usually use, well, it's going to be transferred in like different bytes or different orientation of bytes, and then we can encode it and decode it based on where it is from one side to the other. Because it's really, if you guys didn't know, strings are extremely large. They're very large compared to just regular bytes. That's why we have to encode it in a specific language so that the computer can understand and send it immediately. And yes, Andres, we're going to use import socket. And this should be a built-in function as well as import threading. If it's not, you can just do pip install socket, I think it is. But it should be built in. Are there any questions so far as to the logic? Or if the question is, let's go on, then we'll go on for the last 10 minutes. Any questions so far? So if you're coming here from Hyperloop, this is what the software team is working on, and if you're in the hardware team, this is what you're going to have to. This is what you're going to have to integrate your parts into. Okay. Now for the fun part. we're going to make our server first. And now I have some base code for you, just so that you don't have to make server multiple times, because I do make sure that this works. So I'm going to make another file called server.py. And inside server.py, I'm going to do import socket and import time. So if I highlight over this socket here, it says, it says first it's not accessed, which it's right because I haven't accessed it. And it says this model provides socket operations and related functions. It supports IP, which is Internet Protocol, and Unix domain sockets. And other support systems, it only supports IP. Functions specific for a socket are available as methods of a socket object. And so we have a lot of functions here, but we're going to go over the basics. So I'm going to go ahead and create a socket object using s equals socket dot socket, and then socket.af underscore inet, comma socket dot sock underscore string. Now, I've been using socket for a while, and I still don't completely understand what this is for, but I just know that it's AF inet and then sock string. If you get good enough at this, you can delve deeper into what this means, but all I understand is that it works, and I'm happy with it. So a lot of this I just Googled off the internet. For most of these, you can Google them off the internet, but what you can't Google off the internet is experience. That's what you're here for. So I'm going to go and do set socket. And it's set sock back opt, which is a function call. I'm going to do socket.sol underscore socket, comma socket.so underscore reuse add ABDR. So reuse address 1. I'm going to do s.bind. And here's where things get tricky. So bind is actually a tuple. Bind includes two things. You have your host name. So host equals 127.0.0.1, which is our local host. And then our port equals an integer number, which I'm going to say 1234. Port, I think on any internet service, there's like about 10,000 ports. You can choose any one as long as it's not like a secured one and it's not defined for something else. I like to use 1234 just so it's easy to remember, because we also have to use this for clients. So our port is going to be set as 1234, and then we're going to bind it to the host and the port. So host, comma, port. This. So far in our flowchart here, in our flowchart, I closed it already. We have here, we've done the socket setup, we've done bind, and now we have to do listen. Now listen, we're going to do s.listen for what? And now this script will only listen for one connection and one connection only. And that's pretty much it. It's pretty simple. Now we have to accept. Now before I do accept, I'm going to set this into a while true. And from the previous lectures, we know that the reason we use while true is because of what? Can anyone answer that? We use while true. Never halting Turing machine. Yeah, but we use while true when we don't know what the ending sequence is. We don't know when to end the script. So we want to end the script whenever we want. I guess when our computer runs out of time, then we'll end the script. But for right now, we don't have to just yet. So we're going to do client socket, comma, address equals s.accept. And pretty much what it's going to do is it's going to put the address inside this variable, and it's going to put a dictionary of a lot of information pertaining to the server inside client socket. And what we're going to do next is we're going to print f server established on address like this. And then we're going to create another while true. While true, while true. And what we have in here is we're going to do, so this is the server. So we're going to receive information from the client, right? So we have to use client socket dot recv. And we're going to do receive the number of bytes. I'm going to set it to 1024. This is how many bytes it's going to receive through the socket here. And I'm going to do dot decode. And I'm going to decode it in UTF-8. Now, UTF-8 is kind of like the language we're decoding it in. And I'm going to do print, let's see, message equals this. I'm going to do print message. I'm going to do time.sleep 1. And I'm going to do client socket dot send. And I'm going to encode this inside a byte form. So bytes, I'm going to do message encode. Let's see if it's encode. Oh no, it's not encode. So it's UTF-8. So you specify the language you want to encode it in inside the bytes function. So you have decode and encode pretty much. All right. Message. So what it's going to do is, because this is the server, we're going to send a message to the server, which is going to print here. We're going to wait 1 second, and then we're going to send it right back. And this is pretty much our echo protocol here. Now, what we need to do next is create the server. I mean, to create the client, because we have one side of a server, and we have one side of a client, and we must do a handshake so we can communicate with each other through the socket. So I'm going to do clients.py. And over here now, we will go back to our flow chart, our handy dandy flow chart, to see what's going on. So for our client here, we're going to run the socket information again, and then we're going to connect. We're going to connect to our server. And then from there, we can run our while true and send information over. So I'm going to go ahead and, again, I'm going to import socket and import time. I'm going to go ahead and do s.s is equal to socket dot socket. Let me just make sure it's client socket to receive, right? It's not sent. I don't think this is. I'm sure here. Okay, this might be wrong. I might have to do it's s dot receive. Yeah, it might be s dot receive, not client socket to receive. There we go. S dot send. Okay. The reason why I confused it is because this is what happens, or the client socket contains the information and S contains the actual object used for running the code. And so here I'm just going to copy and paste the same kind of deal. So this is the socket AF inet, and then the socket sock stream. And then I'm going to do s.connect. Oh, before I do that, I have to make sure I have the correct host name. So host is equal to 127.0.01. And my port is equal to 1234. So something like that. I'm going to connect it to my host input. So this is to connect to the server. And after this, I'm just going to run while true. And I'm going to say my message to send is equal to input. I'm going to do print enter in a message to send to the server. This, and then it's going to put it's going to ask the user for an input, and it's going to put it in a message to send. Now what I'm going to do is I'm going to do s.send message equals s.send. And I'm going to encode this in bytes. So bytes, and then message to send in UTF-8, the language in which we're encoding this. And then after this, I'm going to do time.sleep 1. And then I'm going to do message equals s.receive 1024, and then .decode in UTF-8. I'm going to print this. Alrighty. Now, I haven't tested this. I just coded this based on previous knowledge. So I'm going to see if this works. Now, in order for us to know if this works or not, we have to first go ahead and run this script from the terminal. We have 1 minute left, so I can see if I can get this on first try, which I'm probably not, to be honest, but we'll give it our best. So I'm going to show an Explorer. And here's a cool trick if you want to run commands in command prompt. Just left click on the top bar here and just type in CMD. And then it'll open up the command prompt inside the right directory. Yeah, it is possible to do encode as well, but encode is a little bit tricky in the case that sometimes it'll encode it. It'll add an extra blank character into the string, which will break the system. I like using bytes better because it doesn't give that extra character at the beginning. It's like an empty character. Usually most programs ignore it, but sometimes it just like messes things up, especially when you're talking with serial connections as well. Because when we work with serial through an Arduino and a Raspberry Pi, they have to pass the data through the serial and through a packet, which is a struct data type inside of Arduino, which we may talk about later, but it's not important as of right now. When we're importing that into the Raspberry Pi and we use encode, what happens is that it sometimes includes a blank character at the beginning, which the code doesn't recognize, so it throws an error. And if we just ignore the error, then it runs completely fine, but we most likely want to ignore that at all costs. So I'm going to go ahead and do Python 3 server.py. And it ain't loading, which is not good, which means I messed something up. Highlight portion of command window. That's post port. Doesn't seem like it doesn't seem to be connecting. Let me check if my code is right. All right. Doesn't seem like to be working, which is not good. Let me check a reference real quick to make sure I did this correctly. And so it is 302, so we're shifting into our next workshop very soon, which is the 3D Printing 1 workshop. Just need to make sure that I have this correctly so that everything is fine. So 127.0.0.1. Oh, did I put this inside? It shouldn't matter. I like debugging people. Buffer size 8162. Yes, line 15 is printf. I don't know why it's not connecting. That's odd. AFINet, sock stream, bind to host port. Oh. I don't think this is used anymore. Yeah, let me just copy and paste the sample code to see if it's if it works, because I think I'm using the same thing. No problem. Yeah, this is the exact same thing I'm using. I just don't think my program is liking it right now. All right. I'll go ahead and put the right code inside the description of the YouTube video when I do get the sample code working, so that you can use this as a I guess template in your own programs and scripts. But I don't want to waste your guys' time. So I've explained the basics of socket, although the code doesn't work. I'll put the correct code inside the description, and hopefully you'll be able to get that run when I post the video. All right, so as of right now, thank you everyone for attending today's workshop. Let me just go ahead and share the last slide. Are there any last questions before we move on to 3D printing? Because I know I started like an hour late. Or not an hour late, 5 minutes late. Yes, there is a CPP Hyperloop Discord. That's why I'm sharing the ending slide. You can go ahead and take a picture of that QR code or use the Discord link to go ahead and join it. I will also post the code there once I get it to work because this frustrates me. Pretty sure my code is right, but it's just not connecting. So, because if it connects, it should say the print server established on address, but unfortunately it's not. So it must be getting stuck up here. All right. Thanks for coming, everyone. Next week, I believe it is going to be the soldering workshop with IEEE. So we'll go over some good soldering principles and how to solder correctly and how to solder easier if you don't know how. Spoiler alert, it's mainly in the materials. But I'll go ahead and let you guys go. If you guys want to stay here and watch Alex's workshop, I highly suggest you do because it's very interesting. But that's all for me today. So thank you, everyone, and I'll see you guys next time. Bye.